What if the universe decided to put on a show? Not just any show, but a performance so rare, so perfectly timed that it would leave scientists speechless and make the rest of us question everything we thought we knew about cosmic coincidences. This isn't science fiction. This is the story of a real, mind-bending event that unfolded over just 4 days. Welcome to the incredible mystery of the 96-hour convergence. Imagine this. You're an astronomer pointing your telescope at a familiar patch of the night sky. You're observing a pulsar, a type of spinning neutron star that acts like a cosmic lighthouse, pulsing with incredible regularity. These objects are the clocks of the universe, so reliable you could set your watch by them. But on this particular night, something is different. Without any warning, this distant pulsar suddenly flares, brightening by a staggering 40%. For a brief, brilliant moment, an object that was once only visible to the most powerful observatories becomes bright enough to be seen through a decent mid-range telescope. Astronomers around the world are scrambling. Pulsars just don't do that. It's like finding out the sun decided to flicker. What could cause such a stable cosmic entity to suddenly change its behavior so dramatically? Before anyone can even begin to formulate a solid theory, the universe has another surprise in store. Just hours after the pulsar's baffling performance, our own planet decides to join the act. Halfway across the world, along the volatile Pacific Rim, not one, but 2 volcanoes erupt. This isn't entirely unheard of. The Ring of Fire is a geologically active region, but these weren't just any eruptions. They were powerful, nearly simultaneous, and located in a way that suggested a deep, connected pressure release. It was a rare double event, sending shockwaves through the Earth's crust and plumes of ash miles into the atmosphere. On one side of the ocean, the sky is glowing from a celestial anomaly. On the other, it's being darkened by terrestrial fury. From a scientific perspective, the two events are completely unrelated. One is happening light years away, a drama playing out in the graveyard of a dead star. The other is a violent geological process deep within our own planet. The timing is just a coincidence, right? A wild, improbable coincidence. But the show wasn't over. The grand finale was yet to come. As the Earth was still trembling and astronomers were still staring in disbelief at their data, a third silent event was sweeping across our planet. A massive geomagnetic surge, a wave of energy, rippled through the Earth's magnetosphere. This invisible shield that protects us from solar radiation was hit by a powerful disturbance. Now, geomagnetic storms happen, usually caused by solar flares from our sun. But this one was different. It didn't seem to correlate with any significant solar activity at that moment. It was a rogue wave, and its timing was, for lack of a better word, perfect. Because at the exact moment this surge washed over the Earth, something else was making a dramatic entrance into our cosmic neighborhood. A newly discovered comet, a dirty snowball from the outer reaches of the solar system, was making its closest approach, skimming the edge of the inner solar system. So let's recap the timeline. Within a span of just 96 hours, a distant pulsar flares to an unprecedented brightness. 2 major volcanoes erupt in a rare double event on the Pacific Rim, and a massive geomagnetic surge hits Earth at the precise moment a new comet makes its closest flyby. Any one of these events on its own would be noteworthy, a topic of discussion in scientific circles for weeks. A pulsar brightening by 40% is a career-defining observation for an astronomer. A double volcanic eruption is a major geological event. A powerful, unexplained geomagnetic surge is a puzzle for space physicists. But to have them all happen together, clustered into a neat 4-day window? That's not just noteworthy, that's statistically absurd. This is what researchers later dubbed the 96-hour convergence. The name is key. They didn't call it the 96-hour cataclysm or the 96-hour apocalypse. The focus wasn't on the destructive power of each individual event, although the eruptions were certainly dangerous. The true marvel, the central mystery, was the convergence itself. The sheer, impossible timing of it all. Scientists are people who live by numbers, by probability, by the cold, hard logic of statistics. And the statistics for this were just broken. They didn't make sense. When they started running the numbers, the odds of these 3 distinct, seemingly unconnected events happening in such a tight cluster were astonishingly low. The most conservative estimates put the probability at less than 1 in 10,000. That's already deep into highly unlikely territory. but some calculations, depending on the specific models and variables used, pushed the odds even lower, into the realm of 1 in a million, or even more. It was the statistical equivalent of being struck by lightning while winning the lottery on a boat that gets hit by a meteor. Let's break down why this is so baffling. In science, we look for cause and effect. If event A happens, we look for what caused it. If event B happens at the same time, we ask if A caused B, or if B caused A, or if some unknown event C caused both. But here, the events were separated by vast unbridgeable distances and entirely different physical principles. A pulsar is a stellar remnant governed by the laws of general relativity and quantum mechanics, located trillions upon trillions of miles away. Its light takes years, centuries, or even millennia to reach us. So its flare actually happened long ago. A volcanic eruption is a geological process driven by plate tectonics and magma pressure deep inside our planet. A geomagnetic surge is an electromagnetic phenomenon in Earth's upper atmosphere, usually tied to our sun. And a comet is a piece of ice and rock on its own orbital path, governed by the gravitational pull of the sun and planets. There is no known physical law, no theory in our current understanding of the cosmos, that connects the internal mechanics of a pulsar to the tectonic activity of Earth. There is no way a comet's flyby could trigger a volcanic eruption on the other side of the solar system. The events are, by all scientific accounts, independent variables. And when independent variables align in such a spectacular way, it forces us to ask some very big questions. Was it just the universe rolling the dice and landing on an impossibly rare combination? Or is there something we're missing? A deeper connection between cosmic events and terrestrial ones that we just don't understand yet? Some scientists, playing devil's advocate, proposed theories that tried to link the events, however tenuously. Could the comet, on its path through the solar system, have shed some unusual, highly charged particles that interacted with the sun in a way that caused the geomagnetic surge? It's a stretch, but perhaps not impossible. Could this same particle stream have somehow interacted with the pulsar's magnetosphere, causing the flare? This is a much bigger stretch, requiring a form of faster-than-light influence or a previously unknown particle that can travel vast distances and interact in very specific ways. And linking any of this to the volcanoes? That moves from a scientific stretch to pure speculation. There is simply no known mechanism for a space event to trigger a specific geological eruption on Earth almost instantly. The mainstream scientific consensus remains that the 96-hour convergence was a statistical fluke. An extraordinary, beautiful, and humbling coincidence that reminds us just how vast and complex the universe is. It's a showcase of probability. Given enough time and enough events happening across the entire universe, even the most improbable things will eventually happen. We just happen to be watching when they did. But this explanation, while logical, feels a little unsatisfying, doesn't it? It's like explaining a masterpiece of art by simply listing the colors of paint used. It's technically correct, but it misses the magic, the feeling that you're witnessing something more than the sum of its parts. This is where the story moves from pure science into the realm of wonder. The 96-hour convergence serves as a powerful reminder that there is still so much we don't know. Our models of the universe are just that, models. They are our best attempts to describe reality, but they are not reality itself. Events like this push the boundaries of those models and force us to question our assumptions. Could there be subtle, long-range forces at play that we haven't discovered? Are there connections between phenomena that we currently classify as separate? Think about it. A few hundred years ago, the idea that the moon's gravity could pull on the Earth's oceans to create tides was a revolutionary and strange concept. The idea that invisible particles from the sun could cause beautiful auroras at the poles was science fiction. What seemingly magical connections today will be common scientific knowledge tomorrow? The 96-hour convergence wasn't a threat. It was a message, written in the language of physics and probability. It was a cosmic wink, a brief moment when the machinery of the universe was laid bare, showing off its capacity for surprise and synchronous beauty. It challenges us to keep looking up, to keep digging deeper into the Earth, and to never stop being amazed by the intricate, interconnected dance of the cosmos. For those 4 days, the Earth and the sky seemed to be in conversation, and we were lucky enough to overhear a few words. The chances of it happening were almost zero, but it happened. And it reminds us that in a universe of infinite possibilities, the line between impossible and it just happened is thinner than we think. What do you think? Was this the greatest coincidence in modern history or a sign of some deeper, undiscovered cosmic law? On a quiet morning, just before the sun peeked over the horizon on September 11th, something strange happened in the deep, silent expanse of space. At exactly 4:19 UTC, a faint, distant star known as a pulsar, PSRR 8214, suddenly erupted in brightness. This wasn't a subtle flicker. It was a massive surge, so powerful that it momentarily confused automated survey telescopes in Hawaii and Japan. Before a single human astronomer could even lay eyes on the raw data, sophisticated computer systems were already sounding the alarm. They flagged the outburst as a significant anomaly, a cosmic event that demanded immediate attention. Within minutes, the astronomical community was buzzing. Scientists from observatories all over the world began scrambling, sharing their data, comparing readings, and frantically trying to make sense of what they were seeing. Was it just a technical glitch? A simple sensor malfunction? Or were they witnessing the start of something incredibly rare, a truly unique celestial event? It didn't take long for them to confirm their suspicions. It was the latter. This pulsar was behaving in a way they had never seen before, and the mystery was only just beginning. Just as the world's astronomers were grappling with this puzzle in the sky, another drama was unfolding deep within the Earth. Barely a day after the pulsar's outburst, at 15:04 local time, the ground beneath the Kuril Islands, a volcanic archipelago in the North Pacific, began to tremble violently. A deep, powerful tremor ripped upward from the planet's crust, culminating in a spectacular and terrifying eruption. A massive plume of ash rock and superheated gas shot nearly 18 kilometers straight into the atmosphere, painting the sky a dark, menacing gray. It was an eruption of incredible intensity, a raw display of nature's power. But what really made scientists and volcanologists around the globe raise their eyebrows wasn't just the eruption itself, as impressive as it was. It was what happened next. A mere 9 hours later, a second volcano, located more than 600 kilometers away and considered completely unrelated to the first, roared to life without any of the usual warning signs. It wasn't a minor steam vent. It was another full-scale major eruption. Two massive volcanic events from two separate systems occurring in such a tight time frame is a phenomenon that volcanologists have a name for: spatial stacking. It's a term for when eruptions seem to cluster together in a specific region, defying the typical, more random patterns. It's not theoretically impossible, but the odds of it happening are so incredibly low that it is considered an extreme statistical anomaly. So now we had two massive, unexplained anomalies in less than 48 hours. A star that suddenly brightened for no reason, and two volcanoes that erupted back-to-back against all statistical odds. To the public, these were just two separate, dramatic news stories. One for the science section, the other for the world news. But for a select group of scientists and analysts working in specialized fields, this was a pattern, a deeply unsettling one. They began to wonder, could there be a connection? Could some unknown force be linking these disparate events? The initial data was sparse, the theories were wild, but the question hung in the air. What was causing these anomalies? The first real clue didn't come from a telescope or a seismograph. It came from a series of strange reports filtering in from remote locations. Small fishing communities in the South Pacific, isolated research outposts in Antarctica, and even pilots flying long-haul routes over the Arctic Circle all began reporting similar, bizarre phenomena. They described sudden, localized failures of their GPS systems. Not just minor inaccuracies, but complete signal blackouts that lasted for several minutes at a time. On their own, each report was easily dismissible as a local equipment malfunction. But when analysts started plotting these incidents on a map, a startling picture emerged. The blackouts weren't random. They formed a distinct, almost geometric pattern across the globe. It was as if something was methodically probing our planet's satellite navigation network, testing it, and then moving on. When this data was cross-referenced with the timing of the pulsar burst and the volcanic eruptions, the correlation was undeniable. The timeline matched up perfectly. The GPS disruptions had started subtly, just hours after the pulsar anomaly was first detected. This was the first concrete piece of evidence, suggesting that these events were not isolated incidents. They were connected, part of a larger, unfolding sequence that was just getting started. The scientific community was now in a state of controlled panic. What could possibly link a distant star, two volcanoes, and our global positioning system? The leading theory, as outlandish as it sounded, was that the initial pulsar burst wasn't just a natural stellar event. Some hypothesized that it was an energy wave, a focused beam of some kind that had traveled across the vastness of space and had finally reached our solar system. This wave, upon hitting Earth's magnetosphere, could have created ripples, subtle disruptions in our planet's magnetic field. These disruptions, in turn, might have been just enough to trigger geological stress points that were already on a knife's edge, like the 2 volcanoes in the Kuril Islands. It was a wild theory, but it was the only one that seemed to fit all the bizarre pieces of the puzzle. The idea that a wave of energy from deep space could have such a direct and powerful effect on our planet was a paradigm-shifting concept. It opened up a whole new realm of possibilities, many of them terrifying. If this wave could trigger volcanoes, what else could it do? Could it affect our climate, our biology, our technology in ways we couldn't even imagine? The GPS failures seemed to support this, suggesting the energy was also interacting with our technology. As scientists raced to understand the nature of this energy wave, the anomalies began to escalate. It was no longer just about distant stars and remote volcanoes. The effects started to become more personal, more widespread, and far more unsettling. The first wave of biological anomalies began subtly. In several major cities around the world, there was a sudden and inexplicable spike in reports of extreme, vivid dreams. People from all walks of life, with no connection to each other, started reporting eerily similar nightmares. They described strange, geometric patterns, pulsing lights, and a sense of being watched by something they couldn't see. Psychologists and sleep specialists were baffled. Mass hysteria was the initial easy diagnosis. But the consistency of the reports, the sheer detail and similarity in the dream content across different cultures and continents pointed to something else. It was as if a signal was being broadcast directly into the collective human subconscious. Simultaneously, botanists started observing strange mutations in common plant species. Fast-growing weeds in urban areas began to exhibit unusual spiral patterns in their leaf growth, patterns that mirrored the geometric shapes people were seeing in their dreams. It was a disturbing convergence of the biological and the psychological. The anomaly was no longer just out there in space or deep in the earth. It was inside us. It was in the plants growing in our backyards. The world governments, which had been monitoring the situation in secret, could no longer keep a lid on it. The public was starting to connect the dots. The news was filled with stories of the strange dreams, the mutated plants, the ongoing GPS glitches. Panic began to set in. To prevent mass chaos, an international consortium of scientists was formed, and they held a press conference that was broadcast live across the world. They revealed a fraction of what they knew. The Earth was being affected by an unknown form of energy from deep space. They didn't have all the answers, they admitted, but they were working around the clock to understand the threat. Their announcement, intended to calm the public, had the opposite effect. The confirmation that we were not alone and that this visitor was a powerful, unseen force sent shockwaves through society. The mystery of what was happening was now the only thing anyone could talk about. Was this an attack? Was it a form of communication? Was it simply a natural phenomenon that we were too primitive to understand? The anomalies were no longer just scientific curiosities. They were a global crisis, a fundamental challenge to everything we thought we knew about our place in the universe. The faint pulsar that had flared to life was just the opening act. The real story was just beginning, and humanity was at its center, waiting for the next, inevitable event in this terrifying cosmic sequence. Have you ever had one of those days where everything just seems to happen at once? You spill your coffee, you're late for a meeting, your car won't start. It feels like the universe is conspiring against you. Well, imagine that on a cosmic scale. Imagine the universe itself having one of those days, where everything that could happen does happen, all at the same time. That's exactly what occurred over a baffling 96-hour period. A series of events so perfectly synchronized, it left scientists scratching their heads and questioning the very nature of reality. It all started with a flicker, a tiny anomaly that would set off a cosmic chain reaction. Deep in the Vela constellation, thousands of light years from Earth, a pulsar, a rapidly spinning neutron star, the dead remnant of a massive sun, suddenly flared. Pulsars are cosmic lighthouses, their beams of radiation sweeping across the galaxy with clockwork precision. We rely on their regularity, but this one, for reasons we still don't understand, let out an unexpected, powerful surge of light. This wasn't a normal pulse. It was like a lighthouse keeper suddenly cranking the brightness up to 1,000,000,000. That burst of energy, traveling at the speed of light, began its long journey toward us. Now, a single pulsar flare is interesting to astronomers, but it's not exactly front-page news. It's a distant hiccup in the grand scheme of things. But this was just the first domino. Thousands of light years away from that pulsar, but much closer to home, another drama was unfolding in our own solar system. A massive coronal mass ejection, ACME, erupted from the sun. Think of it as a solar volcano spewing 1,000,000,000 tons of superheated plasma and magnetic fields into space at millions of miles per hour. These happen all the time, but this one was different. It was unusually dense and perfectly aimed, like a cosmic cannonball, on a direct collision course with Earth. A solar storm was coming, and it was a big one. Still, we have systems to predict and prepare for these. Our planet's magnetic shield, the magnetosphere, is pretty good at deflecting them. But remember that pulsar flare? It was still racing across the void, an invisible messenger carrying a secret that would soon be revealed. Back on Earth, while these two cosmic events were converging on us, our planet decided to join the party. In the Pacific Ocean's Ring of Fire, a region notorious for its seismic activity, something unprecedented happened. A series of deep-sea volcanoes, dormant for centuries, began to stir. Not just one or two, but a whole chain of them, stretching for hundreds of miles along the ocean floor, rumbled to life. The pressure built, and they erupted almost simultaneously. Imagine the force required to do that. It's like a string of firecrackers, all going off at the exact same moment. The sheer volume of magma and gas released into the ocean was staggering, causing strange temperature fluctuations and unsettling marine life. Geologists were baffled. This kind of synchronized eruption, without any warning, was unheard of. It was as if the Earth itself was having a fever dream. So now we have three completely separate monumental events. A pulsar flare from deep space, a solar storm barreling toward us, and a massive underwater volcanic eruption. Each one a major event on its own. But the universe wasn't done. The real show was just beginning. As the solar wind from the CME, supercharged and dense, began to approach Earth, our satellites picked up the spike. We were bracing for a geomagnetic storm, the kind that can disrupt communications and power grids. But just as this wave of solar energy was about to slam into our magnetosphere, a new player entered the arena. A newly discovered comet, designated C-2025 Hesperos, was making its own dramatic entrance. Comets are essentially dirty snowballs of ice, dust, and rock. As they get closer to the sun, they heat up and release a tail of gas and dust. Hesperos was particularly active, and its path took it directly across the bow shock of Earth's magnetic field, the very first line of defense against the solar wind. This is where things went from strange to downright impossible. The supercharged solar wind, the freshly active comet tail, and Earth's magnetic field all met at the exact same point, at the exact same time. The resulting interaction was something no instrument had ever recorded. It was a cosmic collision of epic proportions, a light show of unimaginable energy. Our sensors went haywire. The data streams were pure chaos. Scientists who had spent their entire lives studying these phenomena were staring at their screens in disbelief. It was like mixing three chemicals that should never, ever be mixed, and watching the explosion rewrite the laws of chemistry. And remember that pulsar flare from Vela? That initial flicker that started this whole cascade? At the precise moment of this cosmic mashup, the leading edge of its light surge finally reached Earth. It washed over our planet, an ethereal wave of ancient energy from a star that died long ago. The timing was so perfect, so impossibly precise, it felt scripted. For 96 hours, our planet was the epicenter of a cosmic coincidence. Think about it. A pulsar flare doesn't influence volcanoes. Volcanoes don't trigger solar storms. And the sun certainly doesn't time its eruptions to coincide with the arrival of a comet. These events are governed by entirely different forces, separated by vast distances and different laws of physics. And yet, they all converged on our small, blue planet in a perfectly choreographed dance. The scientific community was in an uproar. Some called it the ultimate coincidence, a statistical anomaly so improbable it bordered on the impossible. They argued that in an infinite universe, even the most unlikely events are bound to happen eventually. We just happen to be the lucky or unlucky ones to witness it. Others weren't so sure. They saw it as a stark reminder that our understanding of the universe is incomplete, that there are connections and forces at play that we can't yet comprehend. Maybe randomness has its own set of rules we just haven't learned. But for those 4 days, it felt like something more. It was as if someone or something had hit the shuffle button on the cosmic playlist. And every single track that came up was a 1 in a billion hit. It was a beautiful, terrifying, and awe-inspiring performance that forced humanity to look up and wonder. Are we just living in a universe of random accidents, or is there a hidden order, a grand design that we are only just beginning to glimpse? The 96-hour anomaly gave us no answers, only more questions. And perhaps that was the point. It was a humbling reminder that we are part of something vast, mysterious, and far more interconnected than we could ever imagine. What do you think? Was it a cosmic fluke or a sign of something more? Let me know in the comments below. Thanks for watching, and if you enjoy exploring the biggest mysteries of the universe, make sure to subscribe and hit that notification bell so you don't miss our next video. See you next time.